Hello everyone, welcome to Automation E2E. In this video, we'll dive into everything you need to know about Selenium WebDriver and its architecture. So let's get started. Selenium 4 contains mainly three components: IDE, WebDriver, and Grid. The most popular component of this is Selenium WebDriver. Let's see point by point what WebDriver is. Firstly, WebDriver is an interface in Selenium. In programming, interface is like a contract. It defines a set of methods that a class must implement, but it doesn't dictate how those methods should be implemented. Think of interface as a blueprint for a class that implements it. It outlines the structure but leaves the specific design and the how-to-do details with the coder who implements it. Now let's understand it better. Let's imagine you're a car enthusiast traveling between US and UK. In the US, you are used to driving on the right side of the road, sitting on the left side of the car. Everything's familiar: steering wheel, the pedals, the gear shift, all in their expected places. Now you fly over to UK where it will drive on the left side of the road. And guess what? The steering wheel is now on the right side of the car. Despite these differences, you are still driving a car. The basic action you perform, like steering, accelerating, braking, are the same. You have got a steering wheel, pedal, and a gear shift just like you had it in the US. The interface of driving a car is consistent, but the specific implementation is different depending on whether you are in US or the UK. Now, let's come back to WebDriver. WebDriver is an interface because it defines a common set of actions that a browser should be able to perform. Or let me phrase it this way: it defines a common set of actions that a human will perform with a browser. Basically, it imitates all the actions so as to automate things. These actions include opening a web page, clicking on elements, entering text, and so forth. But just like car in different countries, the specific way actions are implemented can vary depending upon the browser. For instance, the Chrome browser has its own way to handle clicks, page loads, and JavaScript execution. Firefox might handle the same things differently under the hood, but it still offers the same basic functionality. That is, the interface remains consistent. Edge has its own internal mechanism, but again, it adheres to the WebDriver interface. By defining an interface, Selenium ensures that no matter which browser you are driving, Chrome, Firefox, Edge, or any other browser, the basic interface remains the same. You can write your automation script once and run them on any browser that implements the WebDriver interface without worrying about the specific details of each browser's internal working. So, when you code using the WebDriver interface, it's like saying, I want to drive a car without worrying about whether the steering wheel is on the left or the right. The specifics of whether you are using a Chrome driver or a Firefox driver are handled by the underlying implementation. As long as you know how to automate, you can switch between one browser to another browser without missing a beat. In summary, the WebDriver interface provides a consistent, standardized way to interact with different browsers. Just like the concept of driving a car provides a consistent experience despite differences in how cars are set up in different countries. Talking about Selenium WebDriver's hierarchy, it begins with the search context and WebDriver interface, which defines method for browser automation. This interface is implemented by browser-specific classes such as Chrome driver, Firefox driver, Safari driver, etc., each having its own unique implementation for controlling their respective browsers. Additionally, the remote WebDriver class is used for executing tests on remote machines or cloud services like BrowserStack. Now, let's explore what it means when we say WebDriver is an API. To do that, we'll first need to understand what API actually is. In terms of software, an API, that is Application Program Interface, is like a bridge that allows different software applications to talk to each other. It defines a set of rules, protocols for interacting with a software component or a system. Especially, an API allows developer to use predefined functions or methods to interact with another piece of software without needing to know the internal working of that software. WebDriver is an API because it provides a set of methods and functions that we can use to automate web browsers. In order to automate a browser, we need methods that imitate all the interactions that a human would do on a website. Let's take an example of the script that we wrote in our last session. We used driver.get to navigate to the login page. We used findElement method so that we can find the username element. Then we used sendKeys method to send the text to the username text field. And then finally, we clicked on the login button. All these actions were made possible by the WebDriver API. The API provides a simple, consistent way of interacting with the web page while it handles the complex behavior behind the scenes. In essence, the WebDriver API makes browser automation accessible, manageable, and consistent. It allows you to focus on what you want to automate rather than how it is done under the hood. To understand any automation framework, we have to have a good understanding of its architecture. Let's discuss Selenium WebDriver's architecture. Selenium 4 has introduced a refined and updated architecture that enhances performance compared to its previous version. It has Selenium client libraries. These are the libraries that allow you to write the test scripts in various programming languages like Java, Python, JavaScript. These are the same libraries that we saw in our last tutorial. Here you can see them on the website, and we had downloaded this Java Selenium library to write our automation code. This client library contains the WebDriver API, which is used to send commands to the WebDriver. They then invoke W3C protocol. In Selenium 4, the communication between the client and the WebDriver is predominantly based on the W3C standards. This protocol eliminates the JSON wire protocol's intermediate translation, resulting in more direct and reliable communication with the browser. In the older versions of Selenium, that is before 3.8 version, JSON wire protocol was used to communicate with driver. Selenium 4 has largely replaced it with W3C standard. The reason is, while all browsers and their corresponding drivers used to use the W3C protocol, the client libraries in Selenium were using the JSON wire protocol. This setup introduced an extra layer of communication where requests and response had to be encoded and decoded, often leading to compatibility issues. Think of it like this. Imagine a person A only speaks Hindi and a person B only speaks English. To communicate, they need a translator. But if the translator makes a mistake, there is a risk of miscommunication. This is similar to how JSON wire protocol worked. It introduced the potential risk of error because of the translation between these protocols. However, with the recent update, both the client libraries and the browser driver now communicate directly with the same W3C standard. It's like person A and person B both speaking same language, no translator needed, which makes the communication more straightforward and reliable. This shift has significantly enhanced the reliability of Selenium as it reduces the chances of miscommunication error. Now, when you run your Selenium automation script, the client libraries send commands to the specific browser you have chosen using the W3C protocol. Think of these drivers as the essential middlemen, the bridge between your Selenium script and the browser itself. They listen carefully to the commands from your script and then execute these commands within the browser. All these communication happen over HTTP protocol. If you look at the diagram, you'll notice that the arrow go in both directions. This bidirectional flow represents the back and forth communication between the client libraries and the browser, ensuring the command is carried out and every result is sent back to your script. It's a seamless conversation that makes your automation process smooth and efficient. There are different types of drivers, as you can see in the diagram. For Chrome, we have a Chrome driver. For Edge, we have an Edge. Similarly, for Safari, we have a Safari driver. All these drivers are essential part of Selenium architecture, ensuring seamless communication between your script and the browser. In conclusion, the architecture's design allows for smooth bidirectional communication between client libraries and the browser. With the shift to the W3C protocol, Selenium has become more reliable, reducing the chances of compatibility issues and ensuring consistent behavior across different environments. That's all for this video. In the next tutorial, we'll explore the different types of locator in Selenium and how to use them effectively. If you found this tutorial helpful, don't forget to hit the like button and subscribe to the channel. Your support really helps the channel grow. Thank you so much for watching.